This is Jay Landolt. I would like to introduce, in accordance with JL Racing and Affliction Fabrication, AFX Fab, a new volume compensation for shocks. In years past, we've had emulsion shocks, which work great. They use a mixture of air and oil, which you get a foaming effect in the shock. It does create pressure, and to me they are inconsistent because you constantly have air mixed with oil. It's just not an ideal situation. There's such thing as a bladdered shock, and in years past I've come to like the bladdered shocks because we have pure oil in the shock with no air mixture. The air is separated by a thin membrane of rubber that deflects whenever the shaft goes up into the shock body to compensate for the oil displacement. The problem with these is, due to them being rubber and not that much volume compensation, you get a lot of pressure change in your shock. So when the shock is completely compressed, it really wants to shoot out of the body. And then by the time it's at the end of the stroke, there's no pressure really whatsoever, or some reverse pressure depending on what bladder you're using. Now in years past, we have drilled holes in the caps to relieve some of that pressure behind the shock, but even then you have a problem with cavitation. And anybody that's ran bladdered shocks knows that eventually you're going to get air in that shock. If you turn your car upside down after you get done racing it for the weekend and try to move the shocks, you can feel air in them. So to me, I've always wondered, how are we going to fix this problem? Well, when we started with the AFX Insurgent, we were running short bodies all the way around. And so there was an extra set of long bodies. So I figured, why don't we take these longer bodies, use the short shafts, and then I'll have more actual shock bore to play with, and use what's more done in real racing, in Indy cars, NASCAR and such, and use what is called a floating piston. Now the floating piston works the same as a bladder, as it travels up and down in the bore, but only it's solid. So that way there's no deflection, and it doesn't get tight at the top of the stroke and then lose. It's constant all the way through, so you'll have equal pressure in your shock at all times. Now, ideally, you'd want to have that just free floating, but due to like high frequency when you're racing on the track, the shock moves too fast and the floating piston essentially gets lost due to just the frequency of the shaft moving in and out of the shock. It just can't keep up with it. So you have to have some sort of pressure behind the bladder, or floating piston is what we have now. So by doing that, I'm using a spring behind my floating piston to have more of a mechanical linear rate behind it, because as you know, when you compress gas or air, it doesn't compress linear. It's more of a rapid compression, and it gets tighter, 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 whereas a spring you can have more of a linear compression on your stroke. So with that being said, I would like to show, these are my floating pistons. They have a tapered hole to where you can evacuate all the air out of the shock, with a screw with an O-ring seal that will seal off any air from getting in or oil getting out after it is placed in the bore. Now I will do another video showing the actual shock build of these and how to do it properly. After you have this in the bore, I have this conical spring that fits over the head of the bolt. The cap will then ride on top of that and provide pressure on that floating piston to keep somewhat positive pressure on your piston. Now this is an O-ring seal. I have friends in the IndyCar industry that build shocks for a living, and so I contacted some of them for some support on, O-ring crush and design and just how to really do this right. So with the guy that works for a major IndyCar team helped me out with this, kind of getting the specs right on it, and we've come up with something that works really well, and it'll be the most consistent shock you'll ever have. The good thing about these as well is, even if it would happen to push out some oil, the floating piston will travel down in the bore and the spring will take up any slack that's in it. I've noticed so far in testing these that there is no air in the shock after you get done racing. You can turn it upside down, whatever. It is just solid, and you have the same rod pressure throughout the stroke, no matter where it's at in a stroke. So you're going to get the same rebound from the shock being completely compressed, or if it's only compressed a 1/4 inch. And that's the beauty of these floating pistons. I really feel that it'll change the way that we do things in dirt oval from here on out. Here's a shock with the floating piston inside of it. As you can see, I take the cap off. There's the spring, and as I move this piston up and down in there, you can see the spring traveling up and down, which obviously the piston's actually doing that inside the bore, but you can see it better just by leaving the spring on it. And of course that spring acts against the cap, which creates the pressure for the rod to come out. The also other advantage of this is you can tune the spring to have as much or as little rod pressure as you want. Now, based on like high bite stuff, I found that a little bit more rod pressure makes the car a little more reactive. Now, on some loose dirt stuff, where you don't want a whole lot of rod pressure, you want to get the car in the track essentially a little bit better. A little less spring pressure here works a lot better. It deadens out the shock a little bit. So this is using this and these stock low friction X-rings down here will create just the smoothest shock that you'll ever feel. They work great, and you'll have to check with AFX Fab for pricing and availability. I'm going to be working with AFX Fab to market these, so the contact will be AFX Fab, and just contact them for pricing and availability. The kit will include your floating pistons for the car, and then also the longer shock towers to accommodate the longer shock body that we'll be using these floating pistons. It'll be a direct bolt-on replacement for any AFX Insurgent you have now, and it's really going to change the way we build shocks from here on out. Once again, my name is Jay Landolt, and thank you for your time.